Dear students, welcome. Today we are going to discuss multivariate calculus, which is included in 4th semester BSc Mathematics Honors, and paper is MATH 4016. In the last year, we have already done 4 classes on multivariate calculus. Today, I am going to take the 5th class on multivariate calculus. Before that, let me remind you, I gave you some definitions. I gave you definitions of gradient, divergence, and curl. Gradient of I told you that first of all, let me this one. What does this operator indicate? This indicates I cap delta delta x plus j cap del del y plus k cap del del j. Del del j. If phi is a scalar point function, phi is a scalar function, mind that, then it is called the gradient of phi. Gradient of phi, this is equal to I cap delta phi by delta x plus j cap delta phi by delta y plus k cap delta phi by delta j. Let me switch off the j cap delta phi by delta j. And the divergence of a vector point. You see that the gradient of a scalar point function, is a vector point function. And divergence, suppose A is a vector point function. Divergence of a vector point function will be a scalar point function. It can be denoted by divergence of a vector, which you can write I cap delta delta x, j cap delta delta y, plus k cap delta delta j dot a vector, or this can be written as I cap delta a vector by delta x plus j cap dot delta a vector by delta y plus k cap dot delta a by delta z, and you may write it like this. This stands for the divergence of a vector. Summation of this means I cap dot delta a vector by delta x plus j cap dot delta by is like this. It will be like this. And you see that the dot product of two vector is a scalar quantity. Finally, it is a scalar quantity. It is also scalar. It is also scalar. Divergence of a vector function is a scalar point function. And also curl. What is curl? Curl means the cross product of this. This can be written as I cap delta delta x, j cap delta delta y, plus k cap del del j, del del j. Cross a vector, or it can be written as I cap cross delta delta x. You may write like this. This is equal to summation I cap cross delta a vector by delta. Such definitions have already been given. Now, today, I shall discuss some vector identities. Some important vector identities. These definitions were given earlier. Thus, I have reminded you. Number 1, divergence of A plus B. Divergence of A plus B. This means that A and B are two vectors. Divergence of A plus B equal to divergence of A plus divergence of B. Divergence of A plus divergence of B, or you may write like this: divergence dot A plus B. Nabla dot A plus B equal to Nabla dot plus this Nabla dot B vector. Dot B vector. It also stands for divergence of A plus B equal to divergence of A plus divergence of B. Let me prove this. Proof of this. In total, we shall discuss about 11 such type of vector identities. This is number one. Let me prove this. Divergence of A plus B, or you may write it in notation divergence dot A plus B, or you can write I cap delta del del x plus j cap del del y plus k cap del del z. Dot A plus B. A plus B. This is equal to I cap dot delta delta x A plus B plus j cap dot delta delta y A plus B plus k cap dot del del z dot A plus B. A plus B. A plus B. This is equal to I cap dot delta A by delta x plus delta B by delta x plus j cap dot delta A by delta y plus delta B delta y plus k cap dot delta A by delta z plus delta B by delta z. Now we see dot product is distributive. Dot product is distributive. Therefore, you may write like this. I cap dot delta B by delta x plus j cap dot delta A delta y plus j cap dot delta B by delta y plus k cap dot delta A delta z plus k cap dot delta B delta z. Delta B delta z. Since dot product is distributive, means a vector dot B plus C equal to A dot B plus A dot C. A dot B plus A dot C. This has been applied here. This is equal to I cap dot delta A delta x plus j cap dot delta A delta y plus k cap dot delta A delta z. This one. Plus I cap dot delta B delta x plus j cap dot delta B by delta y plus k cap dot delta B by delta z. By definition, this is divergence of A vector. It is nothing but divergence of A vector. Divergence of A plus it is divergence of B. Or you may write it is as divergence dot A vector plus nabla dot B vector. This is, you may write like this also in this notation. Therefore, we have proved this number one. Divergence of A plus B, this is equal to divergence A plus divergence B. Similarly, number two, curl of A plus B. Curl of A plus B equal to curl A plus curl B. Curl of A plus B equal to curl A plus curl B. We write like this. Curl A plus curl B. Now proof of this. This is just write curl of A plus B. Curl of A plus B. This is equal to cross A plus B. You may write like this. This is equal to, it is nothing but I cap del del X plus J cap del del Y plus K cap del del J cross A plus B. Cross A plus B. This is equal to, you may write I cap cross delta delta X of A plus B plus J cap cross del del Y of A plus B plus K cap cross delta delta Z of A plus B. You may write like this. Now, cross product is also distributive. Before that, you may write like this. Delta A, delta X. You may write like this. Cross delta A by delta Y plus delta B vector by delta Y plus K cap cross delta A by delta J plus delta B by delta J. You may write like this. This is equal to, since cross product is distributive, K cap cross delta B vector by delta Z. You may write like this. Because the vector product is distributive, but cross B plus C, not B plus C. It will be a different formula. This is equal to A cross B plus A cross C. A cross B, A cross C. This is equal to, you may write I cap cross delta A by delta X plus J cap cross plus I cap cross delta B by delta X plus J cap cross delta Y plus K cap cross delta B by delta Z. Right? You may write like this. What is this? This is nothing but curl A vector. It is nothing but curl B vector. What is this? It is nothing but, what is this? See the definition of curl. It is curl A vector. Curl A vector, or you may write this cross A vector plus. It is nothing but by definition of curl of a vector function. Or you may write curl A plus curl B. You may write it as curl A, it is curl B. Right? Number 3. Number 3. Suppose you have the first two identities are very simple. Number 3. Phi is a scalar point function. Let phi be a scalar, not vector, scalar point function. Of course, differentiable point function and A is a vector point function. A vector is a vector point function. Differentiate. Then divergence of phi A vector. You notice divergence of a vector quantity is always a scalar quantity. Phi is a scalar, A vector is a vector. In total, phi A vector is a vector quantity. But the divergence of that vector quantity will be definitely a scalar quantity. Divergence of phi A vector, it will be a scalar quantity. It will be gradient of phi. Gradient of phi. Gradient of a scalar function, it is a vector function. Dot A vector. Dot product of two vector quantities is a scalar quantity. Ultimately, you will get a scalar quantity plus phi. Divergence of A vector is also a scalar quantity. Divergence of it. The result will be this. Let me prove this result. Divergence of phi A vector equal to gradient of phi. You see, phi is a scalar quantity, A vector is a vector quantity. The product is a vector quantity. Divergence of that vector quantity will be a scalar quantity, mind that. And here, gradient of phi is a vector quantity. Dot product of two vector quantity is a scalar quantity. And divergence of A is a scalar quantity. Right side scalar, this is scalar. For that, you must put the dot product, dot here. The result is dot, just in place of dot you may write cross, you cannot write like this. That because the gradient of phi cross A vector will be a vector quantity. It will be totally wrong. Now, let me prove this one. Prove. Divergence of phi A vector. This is equal to I cap delta delta x, j cap delta delta y, plus k cap delta delta z, dot product, phi A vector. This is equal to I cap dot delta delta x of phi A vector plus j cap dot delta delta y of phi A vector plus k cap dot delta delta 0 phi A vector. It will be like this. It will be like this. You may write it is a summation I cap dot delta delta x of phi A vector. You may write summation of this. Summation of this stands for these terms, these three terms. Now, this is equal to summation I cap dot the differentiation of the product of a scalar quantity and a vector quantity. You see this. Delta phi delta x A vector plus phi del A del x. This one, you will get this one. This is equal to summation I cap, because dot product is distributive. Delta phi by delta x A vector plus I cap dot phi del A vector del x. Since dot product is distributive, means since A vector dot B plus C, A dot B plus C will be equal to A dot B plus A dot C. A dot B plus A dot C. This is equal to, you may write like that. summation you may write like this. Summation of this plus this equal to summation of this plus summation of this. You may write like this. Now, this is equal to summation delta phi by delta x I cap dot a vector. Why I have written here, I am going to explain this. Plus summation phi I cap dot del A del X. Del A del X. Because A is a vector quantity dot MB vector. This is equal to MB vector. This is equal to M A vector dot B vector. We have applied this one here. Delta del phi del x is a scalar quantity. A vector dot MB vector equal to M A vector dot B vector. A vector dot B vector. We have applied this one. And here I have applied A dot MB vector equal to M A dot B. We have applied this. Right? This is equal to, this can be written as summation del phi del x I cap dot A vector dot, it is dot, plus phi summation I cap dot del A del x. You may write like this. It is independent of this summation. It is also independent of this. Therefore, dot. You may write like this. What is this? What is this? It is nothing but del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap dot A vector plus phi. What is this? It is divergence of A vector. It is divergence of A vector. Divergence of A vector. Because I cap summation I cap dot del A vector by del x is divergence of A vector. What is this? It is gradient of phi. This is equal to gradient of phi dot A vector plus phi divergence of A vector. It will be like this. Gradient of phi dot A vector plus phi divergence of A vector. It will be like this. Therefore, we have proved the vector identity number 3. Divergence of phi A vector equal to gradient phi A plus phi divergence of A. Now, number 2. Curl of phi A vector. Phi is a scalar quantity, A is a vector quantity. Phi of this one. This is equal to gradient of phi. Now you see. Curl of a vector quantity is again a vector quantity. You cannot put the dot product here. It will be cross product of A vector plus phi. It will be curl of A vector. Or you may write in this way phi A vector. The same identity can be written in this way. This is equal to the gradient of phi cross A vector plus phi the curl of A vector. You may write. This also stands for this identity. Curl of phi A vector equal to gradient of phi cross A vector plus phi curl of A vector. Plus phi curl of A vector. Now, let me prove this one. Proof. Curl of phi A vector. This is equal to, you may write like this. You may write like this. This is equal to I cap del del x plus j cap del del y plus k cap del del z cross phi A vector. This is equal to I cap cross del del x phi A vector plus j cap cross plus k cap cross del del z phi j phi A vector. It will be like this. And in summation notation, you may write in this way also. You may write like this. This summation of this stands for this. Now, the differentiation of the product of a scalar and a vector will be equal to summation I cap cross del phi del x A vector plus phi del A vector by del x. You may write in this way. Now let me write here. This is equal to just the I cap cross del phi del x A vector plus I cap cross phi del A vector by del x. You may write like this. This is equal to, write it in this way. Double here also summation will be A vector by del x. This is equal to, now summation del phi del x I cap cross A vector. You may write like this, plus summation phi I cap cross del A vector del x. You may write like this. For this, we have applied this one. Since A cross MB vector equal to MA cross B, we have applied this one. For this, A vector cross MB vector, this will be equal to MA vector cross B. We have applied this. For this, and A cross, it is also of the form A cross MB vector. M is a scalar, A and B are vector quantities, will be equal to M A cross B. M A cross B. We have applied this one also. We have applied this. This is equal to, it is independent of summation, del phi del x I cap cross A vector plus phi summation I vector. You may write like this. Am I right? What is this? delta summation of this. Summation of this. What is this? It will be delta phi by delta x I cap cross a vector plus delta phi by delta y j cap cross a vector plus delta phi by delta z k cap cross a vector. And this can be taken common. A cross a vector can be taken common. Therefore, you may write delta phi by delta x I cap plus delta phi by delta y j cap plus delta phi by delta z k cap whole thing cross a vector. That's we have written this one. But you see this one. What is this? What is summation delta phi by delta x I cap? It is delta phi by delta x I cap plus delta phi by delta y j cap plus delta phi by delta z k cap. It is nothing but gradient of phi. It is nothing but gradient of phi. Gradient of phi cross a vector plus phi. What is this? It is curl a vector. By definition of curl of a vector, it is curl a vector. And it can be written as, which can be written as gradient of phi cross a vector plus phi, this curl of a vector. It stands for the curl of a vector. Curl of a vector. Perhaps you have understood this one, very interesting. Let me try to solve the, try to give you the give you the statement of the identity number 5. Identity number 5. Divergence of A cross B. A cross B. Divergence of A cross B will be equal to, you see, divergence of the vector cross product of two vector quantity is a vector quantity. Divergence of a vector quantity will be a scalar quantity, and the right hand side will be again scalar quantity, curl of a vector minus a dot curl of B vector. You will get this one. A dot B equal to B dot A, but A cross B is not equal to B cross A. A cross B equal to minus B cross A. A vector dot B vector will be equal to B vector dot A vector. But this one, a divergence of this A cross B will be equal to the dot product of these two vector quantities is a scalar quantity. It is scalar, it is scalar, like that. Very easy to remember the statement of the identity. Let me prove this one. Proof. Divergence of A cross B. This is equal to, you may write I cap del del x plus j cap del del y plus k cap del del z dot A cross B dot A cross B dot A cross B. This is equal to I cap dot del del x of A cross B plus j cap dot del del y of A cross B plus k cap dot del del z of A cross B. This is equal to, you may write like that, del del x A cross B. You may write like this. This is equal to I cap dot you may write A cross delta B by delta x, or delta A by delta x, you may write delta A by delta x also. delta I by delta x cross b plus a cross delta b by delta x. You may write like this. Now you may write this first, a cross delta b by delta x plus delta a vector, then you may write this one. First you may write this, then you may write this. You can write in this way also, but you cannot write like this. Delta a vector by delta x cross b. In place of this, you cannot write b cross delta a by delta x. The whole terms, this and this can be interchanged, but these two and these two cannot be interchanged because this is cross product. You know this one. Now you see, it is a vector quantity as a whole. This is also a vector quantity. Perhaps you have understood this one. What I have told you. You may write a vector cross delta b by delta x first, then you may write plus, you may write this one. But this means that this term and this term, whole terms, can be interchanged. You can interchange their positions, but you cannot interchange these two positions. I am going to, just I have told you. Now, this is a vector quantity, this is also a vector quantity. This is a vector quantity and this is also a vector quantity. And the plus is there between these two vectors. Dot, what I am going to apply here, since a vector dot b plus c, this is equal to a dot b plus a dot c. A dot b plus a dot c. I am going to apply this one. A dot b plus a dot c. Dot product is distributive in short. This is equal to summation I vector dot delta a delta x cross b plus I vector dot a cross delta b vector by delta x. You may write like this. This one. Now you may write the summation here and here. Delta a by delta x. Cross b plus summation I cap dot a cross delta b vector by delta x. You may write like this. Now, it is a scalar triple product. A dot b cross c. It is called scalar triple product. Scalar triple product, and it can be written as ABC. And let me remind you, in a scalar triple product, the positions of dot and cross can be interchanged. Positions of dot and cross can be interchanged. This is also a scalar triple product. A vector dot b cross c. It is also of the form a vector dot b vector cross c vector. It is both are scalar triple product. And in a scalar triple product, the positions of dot and cross can be interchanged. Just interchange the positions of dot and cross. Summation I cap cross del a by del x. Cross b. Cross b. Here. We have, oh no, not, it is not cross b, it is dot b. Positions of dot and cross can be interchanged. This, in place of this dot, write cross, and for cross, you write dot. write minus sign here. I cap dot delta b by delta x cross A vector. You may write like this. For this, we have applied in a since A dot B cross C. This is equal to A cross B dot C. Cross B dot C. And for this, A cross B equal to minus B cross A. We have applied these two. For this, we have applied this. In a scalar triple product, the positions of dot and cross can be interchanged. And here, for A cross B, A cross this one, we have written this first and this last. For that, we have to put a negative sign here. This is equal. Now you see here for this. It is independent of summation. You may write I cap cross delta A by delta x dot B vector. You may write like this minus. Here also positions of dot and cross interchange. Interchange the positions of dot and cross. Because in a scalar triple product, positions of dot and cross can be interchanged. Since in a scalar triple product, positions of dot and cross, positions of dot and cross can be interchanged. You see what is this? I cap cross delta A vector by delta x plus j cap cross delta A vector by delta y plus k cap cross delta A vector by delta z. Summation of this stands for this, which is equivalent to curl of A vector. This is nothing but curl A vector. Curl A vector dot b minus. Here also you may write like this. Dot A vector. This is equal to B dot curl A vector minus. It is nothing but curl B vector dot A. Or you can write B dot curl A vector minus A dot curl B vector. This way. You may write like this. Therefore, divergence of A cross B equal to B dot curl A vector minus A dot curl B vector. A dot curl B vector. We have proved this one. Let me prove number 6. Let me write the statement of this and number 6. Divergence of gradient of phi equal to Laplace square phi. This is Laplacian operator. You see, equal to delta square by delta x square, delta square by delta y square, delta square by delta z square stands for this. It is called Laplacian operator. I have already defined it in earlier classes. You may check this one. Divergence of gradient of phi equal to this one. Divergence of gradient of phi. Proof of this. Divergence of gradient of phi. This is equal to nabla dot phi. Gradient of phi. This is equal to this. This is equal to I cap delta delta x, j cap delta delta y plus k cap delta delta z dot delta phi by delta x I cap delta phi by delta y j cap plus delta phi by delta z k cap. This is equal to delta delta x of delta phi by delta x plus delta delta y of delta phi by delta y plus delta delta z of delta phi by delta z. You see, let me remind you the formula, the theory. Divergence, if a vector, what we have applied here, if a vector equal to a1 I cap, a2 j cap plus a3 k cap, then divergence of a vector equal to delta a1 by delta x plus delta a2 by delta y plus delta a3 by delta z. I also proved this theorem in earlier classes. You may check this one. A vector is equal to a1 I cap plus a2 j cap plus a3 k cap. Delta divergence of a vector equal to delta e1 by delta x, delta e2 by delta y. Thus we have applied this. We have applied this, which is equal to, from this, which is equal to delta square phi by delta x square plus delta square phi by delta y square plus delta square phi by delta z square. This is equal to delta square delta x square plus delta square delta y square plus delta square delta z square phi. Equal to nebula square. This is number 6. Number 7. Divergence of gradient phi equal to nebula square phi. If you take the curl of gradient of phi, curl, it is a vector quantity. Divergence of this will be a scalar quantity. It is scalar. Curl of the vector quantity will be a vector quantity, but unfortunately it will be 0. You may write the 0 vector. It will be 0 vector. Now, curl of gradient of phi equal to cross delta phi by delta x I cap plus delta phi by delta y j cap plus delta phi by delta z k cap. This is equal to, you may write that curl, for curl you may write the determinant delta delta x. Here you may write delta delta y, you may write delta delta z, delta phi by delta x, del phi by del y, del phi by del z. You may write like this. This is equal to del del y of del del y of delta phi by delta z minus del del z of delta phi by delta y I cap plus del del z of this delta phi by delta x minus delta delta x of delta phi by delta z j cap plus del del x of delta phi by delta y minus delta delta y of delta phi by delta x. It is k cap. equal to delta square phi delta y delta z minus delta square phi delta z delta x I cap plus delta square phi delta z delta x minus delta square phi delta x delta z cap plus delta square phi delta y delta x delta y minus delta square phi delta y delta x k cap. This is equal to 0 I cap plus 0 j cap plus 0 k cap. This is equal to 0 vector provided phi has continuous second partial derivatives, second order partial derivatives. So that delta square by delta x delta y equal to delta square phi by delta y delta x, etc. Therefore, all the terms will be cancelled. Now let me write number 8. Number 8. We have proved divergence of gradient phi equal to Laplace square phi, curl of gradient phi. Divergence of curl A vector, what will be this? Divergence of curl A vector. A vector is a vector quantity. Divergence of the curl A vector will be again a vector quantity. Divergence of this will be a scalar quantity, but that scalar quantity will be equal to 0. Divergence of curl A vector will be equal to 0. Let proof A vector equal to A1 I cap plus A2 j cap plus A3 k cap. Therefore, curl A vector will be equal to just use this determinant k cap. Delta delta x, it will be del del y, it will be delta delta z, and A1 A2 A3, A1 A2 A3, A1 A2 A3. This is equal to delta A3 by delta y minus delta A2 by delta z I cap plus delta A1 by delta z minus delta A3 by delta x. For I cap, just remove this one, del A3 by del y minus del A2 by del z. For the cap, remove this and this. First write this one, delta A1 by delta z minus delta A3 by delta h. Plus, for this, delta A2 by delta x minus delta A1 by delta y, k cap. K cap. Right like this. This k cap. Now, curl of this is equal to this. Therefore, divergence of curl A vector equal to I cap delta delta x plus j cap delta delta y k cap delta delta z. Divergence. This means you will have to put a dot product, dot this one. Delta A3 by delta y minus delta A2 by delta z I cap plus delta A1 by delta z minus delta A3 by delta x j cap plus delta A2 by delta x minus delta A1 by delta y k cap. This is equal to delta delta x of delta A3 by delta y minus delta A2 by delta z plus delta delta y of delta A1 by delta z minus delta A3 by delta x plus delta delta 0 delta A2 by delta x minus delta A1 by delta y. We have applied the same theory. Since if A vector equal to A1 I cap plus A2 j cap plus A3 k cap, then divergence of A vector equal to delta A1 by delta x plus delta A2 by delta y plus delta A3 by delta z. We have applied this one. What will be this? This is equal to delta square A3 by delta x delta y minus delta square A2 by delta x delta z plus delta square A1 by delta y delta z minus delta square A3 by delta y delta x plus delta square A2 by delta z delta x minus delta square A1 by delta z delta y. Has continuous second order partial differentiation derivatives. If then you will get delta square A1 by delta z delta y, delta square A1 by delta y delta z, etc. From this you will get these two will be cancelled, and delta x delta y delta x, these two will be also cancelled, and these two will be also cancelled, and ultimately you will get 0. You will get 0. Therefore, you will get thus divergence of curl A vector will be equal to 0. Divergence of curl A vector will be equal to 0. Today we have proved 8 vector identities. Another 3 vector identities will be proved tomorrow. I shall take another class on vector calculus tomorrow. Today I want to stop here. Thanks for attending the class. Thank you very much.